Yes, very good evening to all of you. Welcome to chemistry online classes. Thank you for supporting us. And if you like my videos, please put your comments on the comment box. So that increases motivation, that gives motivation to me to do more and more videos about the topic of chemistry. So in previous video, I got a response from a student. So that friend said that, sir, how to balance the equation? I hope the person may be in high school level. So let us go with the high school level topic. So how to balance the chemical equations? Basically, before going to that, just remember what is the meaning of chemical reaction? What is the meaning of chemical reaction? So basically, you should remember reaction is nothing but action. If somebody is scolding us, means definitely we'll rebound either in the positive way or negative way. We will show some action. So here also, when two or more substances combine, when one or more substances combines, those substances takes part in a chemical reaction by breaking old bonds and creating a new bonds with the another substances. That is the point. Okay. So chemical reaction is nothing but the transformation of some substances into a new products. Transformation of some substances into a new products by breaking old bonds and creating new bonds for the formation of products. Is it clear? That is what we call as chemical reaction. So first point you have to remember here, what do you understand about the chemical reaction? What is the meaning of chemical reaction? Chemical reaction is a process where two or more substances like A and B, either they may react each other and it may produces AB compound. So otherwise, let me take one example for the chemical reaction. Burning of magnesium magnesium in presence of air. Burning of magnesium in presence of air. So you're supposed to think that burning of paper also a chemical change. They undergo a chemical change. Burning of paper or burning of magnesium in presence of air, what it produces? It gives a new product. It produces a magnesium oxide. Magnesium oxide. Just remember that. So here, this is what we call as chemical reaction. The action between one or more substances to produce a new product. That is what we call as chemical reaction. Now, we supposed to talk about chemical equation. What is the meaning of equation? Basically, the equations are shortened form of chemical change. Should remember, equations are very shortest form of chemical changes. That means chemical reactions. So here, I have written here magnesium and air, magnesium oxide in words. So what I am going to do now, I am converting that reaction into a symbolic representation. I'll use symbols and I'll use for the reaction, addition. Okay, so for that particular point, I will use plus charge, plus see, what is that, sign. Here I can write magnesium, the symbol of magnesium is Mg, plus oxygen, air. Basically, air contains oxygen. Only oxygen is the gas which is supportive for the combustion. So that is the reason only oxygen can react with the magnesium when it undergoing a burning, correct? No, combustion. So it produces a white powder called magnesium oxide. Magnesium oxide. It produces a white powder called magnesium oxide. What is this magnesium oxide? Basically, you mean this magnesium oxide is white in color. Okay. So now let us come here. So basically, the magnesium, there is no bond in the magnesium because magnesium element, and it combines with the oxygen. Oxygen has double covalent bond. You already know that because of valency of oxygen is 2, that can share 2 electrons to form a covalent molecule, non-polar covalent molecule. When magnesium bond in the presence of oxygen, oxygen breaks its bond. 2 magnesium atoms reacts with 1 molecule of oxygen. This oxygen combines with the magnesium and another oxygen combines with the another magnesium and it produces a 2MgO compound. 2MgO compound. How many magnesiums? 2. How many oxygens? 1 molecule of oxygen. It producing magnesium oxide compound. So this is what we call as the shortest form of chemical change is called as a chemical reaction. The shortest form of chemical change is called as a chemical reaction. Now let us come to the, sir, how to balance it, sir? what is the balancing equation? Why to balance the equations? What is the reason? So basically, you have to remember, in the universe, everything is constant. You should remember. So any chemical reaction should be contains a balanced atoms. Okay, both right hand side as well as left hand side. So I would like to tell, this is what we call as chemical equation. Chemical equation. Chemical equation is nothing but the symbolic representation of a chemical change or chemical reaction is called as chemical equation. Always chemical equations should be represented with the help of symbols as well as formula of the compound. Now, so how to represent a chemical reaction? Look at here. The left hand side of the arrow indicates, the head of the arrow indicates the formation of products. So left hand side of the compounds are called as reactants. Reactants are the substances which undergo a chemical change. And right hand side of the equation, that is arrow mark, we call them as a products. Listen, what you can observe here means, initially the reactants properties are differ when those reactant combines to form a new set of properties. This is what you're supposed to remember about chemical equation. Okay. So now, sir, why we need to balance the equation? It's actually not a balanced equation. I have written, it's not a balanced equation. Why should we balance equation? Why should we balance a chemical equation? What is the reason? What is the reason for this? So I told you, just remember that any chemical change in the universe, that must be a conserved. So that mass of the reactants must equals to the mass of the products. So this law is given by Dalton, that is law of conservation of mass. Law of conservation of mass says that what? I would like to call that law of conservation of mass is nothing but LCM. To obey law of conservation of mass. What is the law of conservation of mass? Law of conservation of mass is any matter during a chemical reaction, it neither create nor be destroyed. So it will not create and also it will not destroy. Neither be create nor be destroyed. That indicates that the number of atoms present in the reactant side must equals to the number of atoms present in the product side. That means the total mass of reactants must equals to the total mass of the product. Total mass of the product including heat as well as light. Some of the chemical reactions produces heat also. That is what we call as exothermic reactions. Now let us come to the point. Why should we balance a chemical equation? Means to obey the law of conservation of mass. What is the law of conservation of mass? Matter during a chemical reaction, matter neither be created nor be destroyed. That is the conservation of mass. To conserve a mass of reactants equals to mass of products, we must know the knowledge of, we have to make the equation equally. That means atoms present in left hand side must equals to the atoms present in right hand side. So that is what we call it as balanced chemical equation. Balanced chemical equation. What is the meaning of balanced chemical equation? Means the number of atoms of elements present in a present in a reactants must equals to the number of atoms of elements present in a present in product side. So this is what about the balancing equations. Okay, just 1 minute. Let us go to the next point of the class, that is how to balance a chemical equation. How to balance a chemical equation, sir? Very simple method we have. We will follow actually two different methods are there. One is hit and trial method, another one is partial method. If you learn completely hit and trial method, that is enough for the high school level, I guess. So partial method you will learn in the higher classes. Let us come to the how to balance a chemical reaction. We learned what you mean by the balancing equation, why to balance a chemical equation and all. What is the meaning of balancing equation? Means atoms present in the right hand side must equals to the atoms present in the left hand side. Exactly correct. Correct. Now how to balance the equation? Which methods we have? We have only two methods. Which are the two methods? Means one is partial balancing equation, partial equation method, and next one is hit and trial method. Hit and trial method. Hit and trial method. So basically here we are going to learn about the hit and trial method only. We don't want, I don't want to disturb you by teaching partial method. I'll take you the class for teaching how to balance the equations by partial method, and okay, I'll take one. Okay, hit and trial method one. So how to balance the equations? You're supposed to think that first we should learn the steps how to balance it. That those steps should come in your mind. Okay, so as soon as when you see the chemical equation or chemical reaction, whatever it is. So first step is read a chemical reaction first. Step 1. What is step 1 means? Convert. Read and convert a chemical equation into chemical reaction, sorry, okay, chemical reaction into chemical equation. We can call this as a molecular equation also. Molecular equation. First step you have to do, the first thing is convert a chemical reaction into molecular equation. What do you mean by that? I'll tell you. First, remember. Second point is, after converting a chemical reaction into chemical equation, we should not supposed to change any chemical composition of the compounds. You should not change the composition of the compounds. Let me take an example. Okay, example. Heating of lead nitrate in a dry test tube. Write a balanced chemical equation for the heating of lead nitrate in the test tube. Okay, you're supposed to remember what type of products will get. Basically, whenever nitrates on under heat, under heat, generally they produces oxides, nitrogen dioxide and oxygen gas generally, but only few nitrates that do not produces nitrogen dioxide. That is what potassium nitrate and sodium nitrate, and ammonium nitrate also do not produces. Okay, we'll discuss later. Now, heating up of lead nitrate in a dry test tube. Listen here, step 1, what you're supposed to do, this is what the chemical reaction they have given. Chemical reaction. So we are getting a theoretical part. Now you should convert that into a chemical equation. First, what you have to think means, we have taken a lead nitrate in a dry test tube. This is dry test tube. We have taken a lead nitrate. What is the chemical formula of lead nitrate? PbNO3 twice. Here, nitrate valency, the radical nitrate valency is -1, lead is 2 plus. So how to write the lead nitrate means Pb is the valency of lead, nitrate NO3 1 minus is the valency. So if the valencies or charges of ions are differ, then you have to crisscross the charges to the opposite ions here and ignore the signs, whether it's positive or negative, just ignore it. Okay, now what I wanted to do, just I'll crisscross the charges. What is the charge of lead? That 2 goes for nitrate. Charge of nitrate is 1 comes for the lead. So after crisscrossing, I would like to write like Pb1 NO3. Listen, nitrate charges, that minus charges overall for the NO3. So when you are going to skip that, when you are going to crisscross the 2, the 2 should be out of the bracket. Out of the bracket you have to put, not inside of the bracket. Okay, so outside of the bracket. If you write here 1 or if you leave the 1, that formula becomes lead nitrate PbNO3 twice. Okay, now we are heating. What we are doing? Just we are supplying some heat energy. you will observe that the initial color of lead nitrate is white in color. White in color. So when you heat, when lead nitrate, basically lead nitrate at room temperature do not undergoes any decomposition. But when we are supplying heat, that lead nitrate breaks their bonds between the nitrogen. Okay, nitrogen. And it produces a yellow compound called lead oxide, PbO. And also it releases a brown gas of nitrogen dioxide along with the oxygen. So these are the products you have to get. Now let us convert that into lead nitrate PbNO3 twice on heat. On heating, listen, they have given the condition on heat. You're supposed to write condition on the surface of on the arrow mark. PbNO3 produces what? Lead oxide, PbO, plus nitrogen dioxide, NO2, plus oxygen. I hope it's clear to everybody. Now step 2, what I told you. Step 2, when we have written a fixed composition of a compound, we should not change the composition. Instead of here actually PbNO3 is there. You should not supposed to put any number within the box. I'll create one box. We should not supposed to change any composition of the compound. For that I'll write a box. Why? Because that minimizes the confusions. Okay, so very simple. I'll write boxes for all the compounds, products as well as the reactants. That indicates that you should not supposed to touch any number and any numerical as well as any chemical composition of a compound. We should not touch. Now let us go to the next one. That is what? So we should not change the composition. Should not change the composition of compounds on both the sides. You should not change the composition of compounds on both the sides. Okay, both the sides you should not change. Now third one. So for that reason I made a boxes. Okay, you just take one pencil and write boxes. We use pencil, that is better. Okay, just to make a box. That is the point. Third one. Now what you're supposed to do? You have to identify the number of atoms of each element present in a compound. What is the number of atoms present in each element of the compound? You should list out the number of atoms of elements present in the compound. Just a minute. Okay, present in the compound. Very simple. So you just write down the number of atoms present in the compound. What is the number of compounds present in the list the number of atoms. Now look at here. List the number of atoms present in compounds. Very simple way I am teaching. Now write down the equation. PbNO3 twice on heating. Heat can also represented by the delta. PbO plus NO2 plus O2. I just made a box that avoids me from the confusions. Okay, that avoids us from the confusions. Now third one, what they have telling, list out the number of atoms present in compound. So lead, how many leads are there? Pb is one atom. Lead nitrate is composed with one atom of lead. And look at here, NO3 twice is there. If NO3 twice is there means this 2 multiplies the oxygen number as well as nitrogen number. How many oxygens are there here? 3 are there. Already in nitrate ion 3 oxygens are there. And outside of the bracket 2 atoms are there. That 2 multiplies the 3. And nitrogen 1 atom is there. That 1 multiplies the 2. So it becomes nitrogen actually 1. 1 into 2 is 2. I supposed to write all the elements, individual elements below that compound. Next, oxygen. How many are there? Initially that nitrate ion has 3 oxygens. That should be multiplied with the 2. Oxygen becomes now 6. Okay, 6. Now this side, what I should do, if this is reactant part, I will draw one line here. That is the best thing. Next, let us go to the Pb. Pb is one atom, oxygen is another atom, and I don't want to write this nitrogen here. Again, it creates a confusion. So the reason I will write that nitrogen below of the product. Okay, nitrogen is 1, oxygen is 2, and here oxygens are 2 atoms. One oxygen molecule made up of 2 atoms. Look at here. First, you're supposed to balance a metal. Pb is there. Yes, here also one Pb is there. Both the right hand side as well as left hand side, 2 atoms are there. No problem with the 2 atoms. Balanced. Nitrogen here 2 is there. Here 1 is there. What I supposed to do? After metal, go to the non-metals. In that non-metals also, you supposed to balance oxygen first. That is easiest method. Just supposed to balance the oxygen. Here 3 is there. Here 1 plus 2, 3. Sorry, here in the reactant side, 6 are there. Here in the product side, 1 present in lead oxide, 2 atoms of oxygen present in nitrogen dioxide, 2 atoms of oxygen present in oxygen molecule. Total 5 is there. I need to convert that into a 6 to balance this equation. To balance both oxygens, I could multiply here by 2. Is it? 2 plus 2 plus 2, 6. It's balanced. Correct now? But this 2 where you have to put, that is the confusion for you. I told you in second step, you should not change any composition within the bracket. Then where should this 2 put? Where should we can put the 2? 2 we will put in front of the compound which contains oxygen. Which compound contains oxygen here? Multiplied oxygen, that is lead oxide. So in front of lead oxide, I will put 2. Now, clearly understand. This 2 multiplies, the 2 is there in the presence, in front of the box. That means the 2 can multiply both lead as well as oxygen. Both lead as well as oxygen. So here, lead also becomes 2. Lead also becomes 2. Next, look at here now. Oxygen becomes balanced. Nitrogen is not yet balanced. Again, lead metal has been changed. In second step, you should go simultaneously to balance the equations. Fourth step I have not written, right? Fourth step, balance the elements, balance the atoms from left, the both sides. Okay, I should be supposed to remember. Here, lead is 2 now, but here only 1 is there. I can multiply here by 2. Now lead becomes balanced. But where should I put this 2? This 2 should put in front of lead nitrate. That means this lead nitrate multiplies lead, multiplies the lead also, and also it multiplies nitrogen, oxygen and all. So what can I do? I will multiply oxygen into 2, 2 nitrogens into 2, 6 oxygens into 2. Is it clear now? Now go to the, again, nitrogen is imbalanced, oxygen also imbalanced. Suppose to first we have balanced the metal. Now let's go to the non-metal. Step by step, okay? Once if you have balanced the metal and non-metal, if still it is unbalanced, then again go to the metal and come to the non-metal. In non-metals also, you're supposed to balance from the oxygen. How many oxygens are there here? Okay, fine. Now here 12 is there, here the 6 is there. It is a lot of, it has a lot of variation in the atoms. So what I'll do, I'll go to the nitrogen. How many nitrogens are there here? 2 into 2, total 4. Total 4, this is 2, this is 12. So here nitrogens are only 1, so I supposed to balance with the 4. Now where can I put that 2? That 4, sorry. That 4 should placed in front of NO2. In front of NO2. Now nitrogen multiplied by the 2. Even oxygen also, 4. Okay, nitrogen multiplied by 4. Even oxygen also multiplied by 4. Now, cross-check the equation. How to cross-check the equation? Now write down, remove the boxes. Finally, you're supposed to write a balancing equation by removing all boxes. And you should remember, you should write the numbers coefficients also. What is that? 2 PbNO3 on heating produces 2 PbO plus 4NO2 plus oxygen gas. Now you can cross check the atoms. Pb, 2 atoms. Nitrogen, 2 2s are 4 atoms. Oxygen, 2 2s are 4. 4 3s are 12. And product side, lead, Pb, 2 atoms. Oxygen, 2 atoms present in lead oxide. Go to the nitrogen. Nitrogen, 4 atoms. Oxygen, 4 2s are 8. And final product of oxygen made up of 2 atoms of oxygen. Lead is balanced. Nitrogen is balanced. Oxygen, 12 atoms is there. Add all oxygen atoms present in the product side. All oxygen atoms. 2, 8, 10. 10 plus 2, 12. So we can call this is well-balanced chemical equation. Well-balanced chemical equation. So wherever if in the examination, wherever the question paper asked to balance a chemical reaction or write a chemical reaction, you supposed to write a balanced chemical equation only. Balanced chemical equations only. So I hope I've taken more than 25 minutes to explain the steps. So this will be helpful for you. So I guess this gives the more information about the balancing equation. We'll meet very soon with remaining examples for the balancing equation. Thank you, and all of you just forward or share or like or comment or subscribe my channel, because whatever the video I will upload, that directly will comes to you. Thank you very much. Subscribe button and bell